I think we can get rolling, let people jump in as needed. So for everybody jumping on, this is our second webinar in a series of 3 for building intelligence. And just to give you a quick recap, I'm Brad Bassa with Synergy. You can see my name and picture up there, as well as Mike presented the first one as well. So if you're coming back, welcome back. If it's your first time, thanks for jumping on. These weren't really designed that if you missed the first one, you can't attend the other 2. So we're just kind of going through some high level information to kind of do some education to all of us within this industry. So a quick recap before we get into some things is, our first one was just going over the basics of building intelligence, right? It's a word thrown out there a lot, whether it be building intelligence, smart buildings, things like that. And just kind of going over what that means, what it means to facility owners, what it might mean to engineers, what it might mean to integrators, and how to kind of work through those landmines of actually, do I have a smart building? If I don't, what does it take to get a smart building? And then once I have something, how do I maintain that, and how can I be even better moving forward? So it's kind of a brief recap on what we did. And Mike, did you want to jump in and give them a little bit of housekeeping and stuff before we get into the meat of it?
Yeah, on the housekeeping side of things, if you have any questions, just please throw it into chat and we'll address all the questions at the end of the webinar. And then also after the webinar, we'll send out a PDF copy of the slides and we will send out the recording within 2 weeks. So if you got any questions, just throw it in chat and we'll address them at the end. Get started. So the agenda for today, so we're going to cover a more in-depth review of the controls and integration and understanding the source of your data, and introduce fault detection. What is fault detection? And then we wrapping it up and talk about any questions that we have.
Cool. And real quick, just to touch base, if you missed the first webinar, let us know in chat and we can get you a link to that as well. It will be posted on our website soon, but if you want to see that right away, the next couple of days or something like that, just shoot us a note in the chat and we'll get that over to you. So, all right, as we get into this, we talked a little bit about the overviews of building intelligence in the first one. This one, we kind of want to get a little bit deeper into the weeds, not too deep. I mean, we can go and talk all day long and get really detailed in terms of controls and integration, but we kind of want to keep it at a high level and just kind of share some things to look for and things we can do with controls and integration and how it applies not only to intelligent buildings, but analytics, monitor-based commissioning, and things like that. So why do we have controls? We touched a little bit about this on the first one. And, controls are basically meant to control buildings efficiently when they're not operating at their design capacity. And when we talk about design capacity, we're talking about design days. So as a design engineer, I'm looking at the design days for heating and cooling, basically the worst case scenario that building is going to see in both conditions. And that's how, for the longest time, and, the buildings need to be able to keep up with the high and low ends of weather. But that only happens about 1 to 3% of the time when we're designing those buildings, which basically means that 99% of the time, it's going to operate somewhere in between those 2 extremes. And that's where controls come in. Controls are designed to help us as building owners and engineers to operate buildings at peak performance without sacrificing any type of occupant comfort. If you're in hospitals, patient safety, patient comfort, to operate those buildings efficiently and correctly during that 99% of the time when it's not at a design day. And what do we see when we go into our buildings? We see that too often the controls are scaled back. They're not necessarily, explained correctly to owners, end users, and things like that, and the actual importance of controls. So what we see is a lot of value engineering happening when it comes to controls, whether it be points taken out, sensors removed, non-essential, non-code minimum type things being removed from systems, which is great for first cost. But it really adds up and will destroy that first cost almost within the first year in terms of not having those controls. Because when you're taking those controls out and those parts and pieces, what you're really doing is you're taking out a potential sequence of operation or a potential schedule that we could deploy that would help that building operate more efficiently during that 99% of the time when it's not at peak design day.
Even those utility meters, they'll VE out, right? You know what I mean? They get the VE, they'll VE out something that is so important in terms of just measuring overall building performance. You know, I mean, like in terms of benchmarking. So if you don't have those things, then that becomes a big problem.
Yeah, I mean metering as well too. Fortunately, I think a lot with the way this industry is going, a lot of the equipment that is out there, there's metering designed into a lot of the equipment now as standard, but still, yeah, you're absolutely right. It's unfortunate because then it really limits that end user, that building, and potential engineers and integrators that do work at this building for the next 10, 15, 20, 50 years life of that building. Are you really hamstringing yourself early on for initial cost savings? And cost savings is huge, especially on new construction. I mean, there's not unlimited buckets of money for people to use, but the point of all this is to say, as an engineer, as a designer, as a facility owner, is to really fight for a lot of this stuff, and do it with a return on investment, and show that first cost shouldn't be the sole decision making process when it comes to things like this, because in the long term, in terms of energy efficiencies lost, and especially operational maintenance, that you're going to spend more money on throughout the years by not having some of these controls in place is huge. So what are controls? Let's talk a little bit about the different types of control systems. So, keeping it at a high level, kind of wanted to hit on 3 different points in terms of what we normally see in the industry in terms of control systems, right? So we have proprietary, we have what I like to call kind of open controls, and then we have open controls. So when we're talking proprietary controls, these are control systems that are basically sole source. They're one manufacturer. One manufacturer designs, supplies the equipment. It's their communication protocol between the pieces of equipment. They're the only ones that can work on it. They're the only ones that can service it. If you need a sequence of operation or a schedule changed, in most cases, you have to have that same contractor come out and do that work. So not that their controls are bad in terms of functionality, but in terms of giving you, the end user or the facility operator, the liberty to pick and choose what you want to use, and to actually do a lot of the operational maintenance on your own. You're extremely limited in that. And you're also limited moving forward in terms of when you expand your building or add renovations or do different things to different areas of your facility. You're kind of locked in, because in order to go to a new controls manufacturer at that point, it costs a lot of money to do that. And if people don't know that, if there's new leadership that comes into the facility, that's a lot of the cases when you go out to a building as an engineer, an integrator, or service tech. You can walk out to a hospital, let's say, and you sit down and you say, show me your building automation system, and they show you 3 separate monitors because they have 3 separate control systems. And that's kind of what this leads to, is that it creates these little silos that are very hard to manage and don't really have the best interest, long-term interests of the facility in mind. So we go into kind of open. So kind of open is kind of where, BACnet and Modbus kind of fall in. I'm sure most of the people have heard of BACnet, and BACnet is a great way of getting data out of buildings. And it is open to an extent, but BACnet really depends on how it's designed and deployed within a facility to how open it truly is or is not. We've seen kind of what we see there on the left is a building automation system where basically everything downstream of the server that's pulling all the building automation system in it, that server is spitting out BACnet, but basically everything downstream of it, in terms of the controllers, all the field devices, is all proprietary. So somebody can come in and say, yeah, I have an open BACnet system, but it truly isn't, because when you get down into the field and unit level controllers, you're limited to that manufacturer. You can't just walk in and take one manufacturer's piece of equipment out of that system and put in somebody else's. It just doesn't work that way. So you're very limited in systems like that. And then when we get to the third one, then we talk about open systems, which, those are the Tritium Niagara versions of software, of building automation that we are starting to see more and more of, just because owners, engineers, integrators have done a really good job of getting the message out there to say, hey, I want more control over my building. And I want more control over the software and the tools that I'm using. And that's where we come into, open communication and open protocol. The picture on the right there, it says open is a portion of an OT network or an operational technology network, that allows us, or allows the user, the engineer, the integrator, to kind of swap parts and pieces on that network based on different Niagara components. They could be manufactured by any number of different manufacturers, but they all speak the same language. And where this becomes hugely beneficial to the owner and end user is the life of the service life of these types of systems, where you're not tied into one service provider or one manufacturer to provide all your parts and pieces of equipment. You can go out and based on your financial requirements, you can have different service providers working on this equipment for you, and even have people on staff go get certified and trained on these types of communication BAS protocols and do the work yourself. It allows great flexibility and really should drive down what we talked about earlier, your first cost of doing work in terms of adding controls and building automation to your facility.
Yeah, it really helps with holding those contractors accountable, you know what I mean? Because, project team is as good as the team themselves, right? So, and there's turnover within companies. So you might have one good vendor that's got a great team, but in 5 years that might all switch. They might, start not performing. So that ability to be open gives you the flexibility to go to a different contractor to meet your needs.
Yeah, and I think it touches base to what we talked about in the first webinar is having some standards and specs when it comes to building automation. That's critical because too often it's there's just a couple notes on a drawing that say provide building automation as per manufacturer standards or per existing standards. But when you kind of take that ownership back of those standards and specs and direct your contractors to put in the things that you want versus what's best for them, it really makes a big difference moving forward.
So what do we mean by integration? Brad talked a little bit about the different, proprietary, kind of open and open. And so for some of the controls are all done by the controls contractor, which can give you the most flexibility, right? So the most flexibility is that you do an open system and your controls contractors install everything and it's all controlled with their equipment, right? So that's the most flexibility. Other systems, you might have a controls contractor installing the backbone and doing things, but your equipment might be factory controlled. So you might be going into a piece of equipment, an asset, but it's got all the controls all internally taken care of. So that gives you some visibility, but it doesn't necessarily give you the read and write capabilities, which makes it challenging. And then, as Brad mentioned, with the different types of systems, being able to get that data out from the proprietary ones, that can be done through their proprietary network. Sometimes you can try to get BACnet out of that. That is a little bit harder on the proprietary side. So sometimes they communicate over, those three different ways. Sometimes you're going to have all of it controlled by the factory. Sometimes it's going to be open, and so that's kind of the main function of how we're communicating within those controllers.
And that really, Mike, to that point in integration in terms of, if you have things kind of teed up for you as an integrator or as an engineer coming into a building to start pulling data out, that could really mean the difference between starting to see data and trends, into your analytics and fault detection program within minutes or within weeks and months, because that could really be a giant bottleneck. Even if somebody says they can get BACnet out of your system, it really does take, some time and effort and coordination between yourself, the building owner, their proprietary systems that are there and things like that. So it could really be a bottleneck.
And that kind of talks about the next point here is how is your BAS data communicating with you, right? Do you have visibility, right? You want to have visibility into your facility because your building data is important to how well your building runs. And if you don't know if you don't know what your data, where it is or what's going on, you got to ask, where is it and how can I get it working for myself? Because sometimes you get put into that situation where you could have a 250,000 square foot building and you might not be able to get any information out of that. And that information is critical to your cost of your bills. Sometimes you run into issues with the metering. If you can get metering in, then you can actually validate your bills. So if you don't have that data, then you're just really playing from a short deck, and it's really going to hamper your operation. So the best thing to do is to talk to your controls contractor and really figure out, how can I expose that data? What is the best way for me to do that? And then once you kind of talk to them, you can get access and you can talk about that, and that open information can start feeding a fault detection and diagnostic platform, right? So you have your building automation system at one level, and then the fault detection sits on top of that. But if you can't feed that data to it, then you don't have any ability to, fight the drift, right? So drift is something where your points start to come out of calibration and there's changes, or maybe your sequence of operations, that information to your fault detection platform allows you to put in some really strong rules and different things to help improve your energy performance, and things of that nature.
Yeah, and it sounds so simple to say, hey, are your points named correctly? And people might shrug that off, but it really is amazing how critical, whether it be point naming or just getting your hierarchies correct in terms of your parent-child relationships. It's so critical, and too often it gets passed over. That type of integration, you think you just bring, you're writing a sequence of operation, you walk away and forget it. But if your VAVs downstream are not tagged to the correct air handler, you could have the greatest static pressure reset sequence of operation ever written. But again, if those hierarchies and those point naming structures and naming conventions aren't correct, it's never going to work. And then, that's, hopefully you're going to catch that, with your analytics. But at the same time, that just goes to show you how critical having a hierarchy or those relationships can be. It can really make or break the entire sequence of, an air handling system with 50, 60 VAVs, downstream of it.
Yeah, I mean, the fault detection side of it, if you can integrate it, it will really give you a complex trend of the system, not necessarily just a trend of one point and watching one sensor, for sure. So you can kind of, we talk a little bit about the sequence of operations and the utility metering, wanting to integrate those into your platform so you can use those as tools to benchmark and make sure your building's running efficient as possible, eliminating drift, reducing that energy cost.
Yeah, so we look at, touched on a little bit before, we've been heavy on the building automation in terms of getting your data, but, there's plenty of other areas that we're looking to, use data to make ourselves and our buildings better. We talked about building automation system, which is a good chunk of it, but, we're also looking at trying to do integrations with your maintenance management system, your CMMS, your asset management system, your utility meters. The asset management systems are very, very big, and they're coming on strong now because they can give you a lot of data, right? You're logging your chillers, your air handlers, your pumps, and tracking how they're performing. And when you pair that with analytics and fault detection, and we'll get into it in a little bit, it can be very powerful because you're not only seeing how your assets are performing in real time, but you're seeing how their performance now is going to impact their actual useful life across their performance within your building. So if you can extend an air handler or chiller from a useful life of 20 years to 25 years, I mean, that's significant. You're extending your deferred maintenance and deferred capital costs for replacing that out, and that's big. And you can plan for it a little bit better, right? You're not waiting for something or expecting something to fail. You're planning for it, right? You're doing enough investigation so you can start planning your capital dollars so they're available when that machine is being ready to replace. And what we talk about too is bringing in all these points of data, and it's great to see all that. But one of the biggest things that you get out of bringing all these points in is you start to see the data you don't have, and that's the gap analysis that we talk about to say, hey, I have all this great stuff, but what can I see? And what those gaps that I don't have, what gaps, those gaps represent dollars. They represent dollars lost. They represent efficiencies lost. So to say, hey, I have these gaps in my data. If I can fill them for, $1,000, $5,000, $10,000, what will that get me back in terms of ROI? I mean, that just might be replacing a VFD. That might be replacing some temp sensors, things like that, and getting those into your system so they can benefit you in the long run.
Yeah, I mean, to your CMMS point, right? Even asking the same question of, how do I get the data out from my CMMS system? Asking that question is going to put your vendor in check a little bit, because now you're going to start, well, what are you using it for? It's like, well, it's your data, it's your information. You need to be able to utilize that as a way to improve your operation. And they might get squirrely on that, but at the end of the day, it is your data, and it's great to ask that type of question. So why is it so hard to get your data out and working for yourself, right? So, I mean, it is a challenge to get data out, and it's even harder when you have multiple vendors. But one of the best ways to really get your data out is to have a BAS master plan, right? A BAS master plan will help you be able to, look at all the different systems you have, understand their age of those systems, and then you can build a plan so that you can have an end goal. Say, maybe it's in 3 years or 5 years, you want to be fully open. And that would give you the ability to start pulling that information out. And I think that's a big deal. And when, if you look at that plan, you can, you can really just, work with your vendor and get them to update their controllers and kind of get them in line. So you really want to leverage your vendor that you have currently, managing your control systems, and really trying to set up that end game of where you want to go, because at the end of the day, if you have, as you're looking at your plan and you got poor integration, you need to go fix your namings, you've got tagging standards you need to work with. So there's some homework that you have to do prior to being able to get that data out the correct way. Because when you get data out and it's all essentially not tagged or it's not named correctly, then it's somewhat garbage, because you can't do anything with it. There's no standards and different things. And I think that's a big challenge, and you need to know that at the beginning of your plan so you can actually set the right expectations.
Yeah, and I think part of I don't think we've ever been on a call with anybody, whether it be a hospital, a university, or anybody, when we're talking about monitor-based commissioning and data and things like that. I've never really heard anybody say, no, I really don't want more information about what's going on in my building. It's just that hurdle is, how do I get it, and how difficult is it to get it out and make it useful for me? That's usually the biggest hurdle. So that's, we're trying, and that's kind of what the industry is going to. And, like I said, with a lot of the open protocols, that's kind of the real nice thing, is that there's a lot of open source and a lot of smart people that are working on trying to make this easier for all of us.
But even with those proprietary systems, I mean, if you set the plan to say it's a, vendor A and their system, but you can work with them to be like, all right, let's open this up. Let's go to a BACnet protocol, and you can utilize your service contract that you already have with that vendor to start building that database, so that then it can communicate on the trunk with something that you could actually, then you're building that those key foundational pieces so that you can actually have a fault detection layer above your building automation system.
No, very true.
All right.
So let's get to our next portion of this, building automation systems, asset management. Great, we're pulling all this data out. Now what can we do with it all? And that's what we get into in terms of, the analytics and fault detection, which is, it's kind of a snowball rolling down the hill. It's becoming more and more, not even more and more popular, but it's going to be, something that's going to be required more and more across all verticals, whether it be, healthcare, higher ed, things like that, just because the benefit for it is so great. It's already required in ASHRAE 90.1 for economizers. And, if you read a lot of what's going on, especially in the healthcare market, with the pandemic that we're coming out of, ASHRAE, FGI, ASHE, they're all talking about putting it more and more into standards, because they want to be able to verify not just at one point in time that your building's operating correctly and it's maintaining patient comfort, maintaining patient safety, but they want to be able to know that it's doing it all the time, and be able to go back in time and say, hey, prove to me that your building was safe when people were here under X, Y, and Z conditions. So it's becoming less and less a nice to have and more of a requirement. And that really makes all of our jobs, a little bit easier and a little bit better, because we're going to have so much more information to work with, not only doing monitor-based commissioning and doing stuff once buildings are open, but now we can start to use this data to help drive our designs. We can have better designs that are actually based on real data, real systems performance, and things like that. But also it just, it gives you the ability to trend so much and to trend things that you didn't even know you want trended, right? So, I mean, in typical building automation systems, if I want to go trend a temperature, I have to go in there, I have to select that point and start the trend. It's not automatically started for me. And there's typically, that trend will store data for 24 hours, maybe up to a week. When we have analytics and fault detection running with, the way we are now in this industry with cloud computing and things like that, it's trending every point, at whatever interval you're setting it to, and it's keeping it, storing it all the time. So you can go back at any time to be like, hey, I forgot to trend my chiller performance last summer. Well, it's already doing it for you. So now you can go back in, you can compare it to what you're doing this year and have the power of that. And it's just, the unprecedented analysis of systems that it allows you is mind boggling, because now we can not only look at just individual pieces of equipment with trended data, we can now see how those pieces of equipment interact with each other. If we're talking about, a VAV that's demanding cooling, how is that impacting the air handler upstream of it? And how is that air handler impacting the chiller upstream of that? When you overlay all that stuff and take it out of their individual little silos, it really becomes a powerful tool. And one thing that I wanted to touch on earlier, but I forgot, and we'll talk about it a little bit, as Mike moves forward on this, is being proactive with things, right? But by the time something fails or you have an issue, it's too late. You've lost the ability to make a good impact and create efficiencies and possibly energy savings. So what these analytics allow us to do is to go in and find issues before they become issues. And being proactive is where you start to see the big chunk of saving energy, having operational maintenance efficiencies increased. Because you're just not waiting for that other shoe to drop to actually go fix and start something. You're proactive, and if you can fix something 12 months before it fails, what does that 12 months represent? Not only in terms of you having to send a tech out there every single day to maintain it. There's costs associated with that. There's also costs associated with the energy loss because it took you 12 months to actually find that something was wrong. So that's the big, powerful benefit of it, is just having that eye on your systems at all times and waiting and, allowing you to go in and do the deep dive investigation. But one little caveat I have with analytics and fault detection, and we touched on it in the first, webinar, is, your most important asset is yourself. It's the facility operator, it's your engineer, it's your integrator. That human interaction with the system is what drives everything, right? The analytics and fault detection, it's a tool. It's a wonderful tool, but it's still a tool, and it's only going to show you the value out of it with as much work that you put into it, right? So you have to be in there, you have to be doing the analysis, you have to,
take action. You got to take action.
You have to take action, right? So the old adage, nothing changes if nothing changes, right? So I can give you the greatest analytics and reports and issues in the world, but if you're actually not going to go do something and make a change to correct it, then nothing's going to happen.
Yeah, I mean, that kind of goes back to, the root cause analysis, right? So we talked a lot about the proactive side, but the root cause, you could be, you're back to your VAV, you got a space that's warm, and it might alarm every day that the space is getting warm, but it's like, okay, why is that actually getting warm? Did they add different equipment in the room or like what is going on there? And so on your BAS, you could be getting an alarm every single time it goes above that 80-degree mark. But with the fault detection, what it's going to tell you is that you're at full cooling in this, this situation all the time. And then you can actually get to the root cause of, is that undersized, or is it that the upstream at the air handler, is that, undersized or at capacity? So getting back to that root cause analysis and being able to maybe it is this, and then being able to look at that and overlay multiple different points through and analyze that at one time. You just don't get that from your building automation system, which they're not meant to do. The building automation system's really driving to control, and they're driving for alarms and things that are happening between 0 and 24 hours. The things that are going in the past and the ways to really drive efficiencies is to look at the past over time, right? Not just a day, not just a point in time, but it's really to look at how's that asset been performing over the last week, and you can see where it might have its problems, or you can see where it's doing really well. So it really gives you a good opportunity to look at that root cause and eliminate some alarm fatigue, right? So now you can get rid of that alarm that keeps on going off, because at the end of the day, on the alarms, a lot of building automation systems, they get ignored. And if they're getting ignored, then there's really no value in that alarm, those alarms taking place. And
I think, to that point, it always kind of irks me a little bit that people associate the analytics and fault detection with alarms. They're not alarms. By the time you have an alarm, if you're in your analytics and you're using that tool correctly, you should never get to the point where you have alarms. I mean, yes, you're going to have some nuisance alarms here and there, things like that. But at the end of the day, the analytics are meant to be that tool so you can be proactive to head off those alarms that come down the line.
Yeah, I mean, you can use it in ORs, right? I mean, we talk about pressurization, how important that's been recently in the hospital systems, looking at, pressurization of spaces and things, and you can look at that and watch that over time, and you can see when it's winning and when it's losing and make those modifications, and they'll validate your sequence of operations. And, another thing that I find that is really good, because if you put the effort into your fault detection system, which means you're going to focus on meters and some benchmarking and things, it can give you the opportunity to provide real engineering projects that you can reduce your energy consumption, right? One of the goals to reduce our carbon footprint. We want to really drive towards building efficiency, and it's great to be able to track it. I mean, talking about trying to get your management above you, maybe to get something approved. If you can come at them with a project that has a specific ROI, and then on top of that, you can measure that at the end of the day, then it really proves your point in terms of, a new sequence of operations, or a new chiller or a VFD, changing a system from a constant volume to a variable volume. It gives you the ability to measure and verify that operation and see the impact that you're making daily. And sometimes you might not make it, it might not work great for you, right? You could make a bad decision, but the thing is if you measure and verify it, then you're going to see that maybe that was the wrong thing, or, and you can really work to fine tune that building performance.
Yeah, I mean, it really allows you to, if you're going to say you're going to do something, and actually hold a lot of your contractors and vendors accountable as well too, right? So, I mean, if you have, a great metering plan and metering infrastructure in your building and some analytics, and you have somebody come in to do a lighting retrofit or things like that, and they're promising some kWh reductions and things of that nature, you have the power now to actually hold people accountable to their promises, and that in itself makes you more powerful, allows you to buy things and be more efficient. From first cost, we talked about that before, allows you to be more data driven in your decisions.
Yeah, 100%.
So we're kind of wrapping up in terms of where, we wanted to hit here and be mindful of everybody's time, so we can kind of get to some questions and talk a little bit about things moving forward. But, kind of our key takeaways of what we wanted to talk about today was, getting you to start asking questions in terms of your controls and integration across your facility, and what that means, and the benefits of it, and what it would take for you to get to a point where maybe, hey, I'm not using my data the way I should be using it. It's not as powerful yet, to a point where it is powerful, and it's allows you to do some of the things that will make your building more efficient, more powerful. And that's part of what we'll get into in part 3 of this is now that we have the data, what can we do with it? What are the cool things we can do, whether it be data-driven design, new building commissioning, retro commissioning, ongoing monitor-based commissioning. The true power of that, rather than just going in and saying, hey, I'm applying some data, where are some low-hanging fruits and ECMs I could do? Let's actually start using this in our design moving forward, and make it more powerful, and start to leverage the power of all this, not only to have better designs, but to buy our equipment better, to have our equipment perform better for us, have it last longer, and use that to make us more powerful. We kind of hit on where your data is coming from, how hard it is to get out. And that, like we said, is kind of a big wake up call for your building owners to say, why am I having so much trouble seeing my own data? I'm paying for it. It's mine. I know I can do some great things with it, but I can't see it and I can't use it.
You kind of got to make the decision, right? You got to decide do I want to have fault detection as a platform to help me improve my building? You know, and if you do, then you got to start, as you said, asking those questions. But if you say yes to that question, then it's a matter of, all right, let's get a game plan on how we can start talking with our vendors, or, you know, reviewing our controllers and see what we can do to start accessing that information.
Yeah. And you know, the third one there is analytics and fault detection. And it's such a powerful tool. But, you know, what we like to say is, you know, the value's not in the data, the value's in what you do with the data. So it's a wonderful tool, and there's amazing things that you can do with it now, and even more stuff that you will be able to do with it in the future. But again, it's a tool in your toolbox, and your most powerful asset is yourself. You know, as a facility owner, a facility operator, engineer, integrator. You know, every tool that you can have in your toolbox to make you more effective. We need it.
All right, so as we wrapped up, we're going to kind of go through some questions and comments. As I mentioned earlier, the webinar for the PDFs, we'll send those out after we get wrapped up. We'll also be sending out a survey just to, as you know, as we continue to do webinars, we appreciate the feedback of what's positive, what's negative, as we'd like to make the modifications prior to that. And we do have part 3 coming up on building intelligence coming soon. So what do we have for questions? All right. So first question.
Did you get a chance to see those, Mike? Because I've got a couple others that came through.
You can go ahead and read them off if you don't mind.
Yeah. So the first one is, what's the first step for a facility manager to take if they have a closed protocol system and they want to transition into an open or non-proprietary BAS?
Ooh. Right. I'll let you start with that one.
Yeah, I mean, I would say, first of all, you really need to determine if it's truly closed, because even closed proprietary systems, we have the ability to open those up somewhat. And everybody, you know, opening those up is different for, you know, every different manufacturer. Some are easier than others. There's going to be a cost, you know, associated with that no matter what, and some are easier than others. But you know, I would say the first step is just actually doing some investigation to see what it is I have, and what are my limitations, and then go from there. So once again, we talk about a gap analysis. What do I have, and where do I want to get to? And just start asking those questions. And whether you're asking that question of your BAS service provider, they might get a little flustered because they want to know why you want them to open up their system. But then again, that's what we said. It's your data, you're paying for it. Ask those questions. And if you don't think you're getting the right information from that person, I would talk to. And it kind of goes to, I see Nick's second question, it kind of leads in the same thing too, in terms of pursuing a BAS master plan. Either talk to, you know, your engineer, or, you know, another trade that we talked about in webinar 1 that we didn't touch on, you know, too much in this one, but they're deep in this as well too, is talk to a master systems integrator, because they're, you know, brand agnostic, controls agnostic, and will give you good information in terms of what to be looking for, what to ask your current building automation supplier, and what steps to take forward, and actually what can help you lay out, you know, a master plan for migrating and integrating old proprietary legacy systems into something that's a little bit more open and useful for you moving forward.
Kind of in that same vein, I think we have room for one more question. What if someone is told that their BAS is an open system, but they're not sure? What kind of questions should they ask their vendor to verify the openness?
Verify the openness. You know, I mean, once you've done, like, say, that gap analysis, you know, it's good to start talking about what language they're speaking, right? So say if it's a Siemens, if it's a P2, or if it's, you know, using BACnet across the main subnet, right? So inside the network, it's going to be on the subnet. So, you know, you'd start asking them questions in regards to what is the language that they're communicating from controller to controller on through the trunk, would be really what I would focus on.
Yeah, and I would also say, you know, first you need to define what you want or what you think open should be, right? Because we touched on it earlier. If all you want to do is get data out, you know, you can have a proprietary system and get data out of that and analyze it and do things with it. You know, great. That's a level of openness. But if you want to get down to it where you want freedom to put in, whether it be your own field level devices, or be able to mix and match manufacturers of those devices and have the freedom to kind of pick and choose the manufacturers and vendors that you work with, then that's a different question entirely as well too, because then that requires a little bit more planning, master planning, integration and things like that. So, the first thing would be is to ask yourself, at what level of openness are you, quote unquote openness, are you willing
Looking
to
for.
yeah, either looking for or willing to be satisfied with, right? Because a lot of people that say, hey, I got my system in here. Tell me how I get data out. I really love my proprietary system. It's great, but I want to be able to see it on a higher level and do something with it. Great, we can do that too. We can get that exposed and make it quote unquote open. But it all goes to in terms of how deep you want to go with it.
So before we wrap up, we're going to go ahead and share the poll results from the poll that was listed at the very beginning of the webinar. And then you guys can wrap it up.
How many sources? Awesome. Looks great.
Yeah, and we touched on a bunch earlier, whether it be your maintenance management system or even lighting systems. We didn't even touch on that. I mean, we can pull in light if that's not tied to your building automation system. We can pull in lighting, fire safety and security. Right, we can start tracking how our HVAC systems are performing based on how many people are in the building, as well as I would say another great source that we talked about in the first one and mentioned it a little bit as well too for building and facility data is the facility team in-house as well too, right? Because they know the building better than anybody, and they should be the ones that are helping drive a lot of the sequences and scheduling and things like that. So programming is not done without their approval.
Yeah, that goes back to that action piece, right? I mean, you can get it. You gotta see the fault detection, or the failure or the capacity issue or whatever it might be, and get somebody to get eyes on it. Have a tech go out and take a look at it, or yourself, whoever that might be managing that system, is to get some eyes on it and see what's really going on, because you never know. I mean, somebody could have left the door open. You never really know exactly what it is until you see that there's an issue, and then you can kind of get to the root cause and then go get eyes on it. So, all right, well, appreciate everybody coming out today for our second webinar in the series, and look forward to seeing everybody in part 3, where we'll be getting more into the fault detection and some of the some additional benefits from that, and some more ways that you can apply it.